All right, so I've graded the test and posted the grades. Right, everything should be up to date as far as grades are concerned. So I'll call your name. You just come up and grab your test. Cody? Deshaun? David? Javier? Aiden? Megan? Megan V. Jake? Brandy? James? Joanne? Ray? Mary? Denise? Robert Gutierrez? Jacob Sanchez? No Jacob? Megan De Leon? Miranda? Bryant? Raquel? Mariah? And Michaela. I don't recall what the highest score was. I think it was a 105. So I asked you to watch a video for today. I hope you did that. But before we get to that, let's talk about the final. I had handed out a review. Does anyone need the review? Do I remember I handed out this review? So we have to decide as a class if we want our final exam to go back to the beginning or if we just want it to be over what we did. Basically, it'd be like another version of the test that you took now, right? It would be all, logs and exponential and all that stuff, along with what we're going to do today. So let's just take a quick poll and see what people think. Should I talk about the pros and cons of each? The pros would be, if we do the whole semester on the final, then you'll have less of like what we just did on that last exam. If you look at the review, there's only a few problems I would ask you to do from the last exam. If you have the review, it's problems 9, 10, 11, 12, 13, and 14. That's it. You could narrow your focus, your concentration down to just those when you're studying. Or if we don't do that and we just do from logs on, then I can make it more intense, like more of what you did for this exam. Lots of solve equation, interest problems. You know what I'm saying? The question I think you should ask yourself is, do you feel more comfortable with the stuff you did before the exam you just took?
Yes.
Okay. If that's your answer, okay, if you feel more comfortable like sketching a polynomial function, left-right-hand behavior, using the synthetic division, if that's stuff that you're better off with, then I think that you should be in favor of doing a final that covers the whole thing. So let's take a real quick vote. How many of you would like a comprehensive final that would go all the way back but be a little more narrow? Okay? The pro of the other one, if you want to have less material to look at, I guess. I don't know.
Are we allowed to only use one cheat sheet, or could we use like all the cheat sheets?
You could use them all.
Okay.
Yeah. Yeah. Yes. Who else needs them? I'll call your name. Let's see. Cody, Jake. It's Cody, Jake, Denise, Jacob, Megan. This anyone? Okay, so show of hands again. Looking at a final that would be pretty much like this.
Everything?
Everything?
Wait,
Okay, and then let's go the other way. How many of you just want the test to cover what we just tested on? Just, so only 3? How many of you don't want to take a final at all? And we just call it, there we go. Unfortunately, I have to give a final. We are required to give finals. So, in fact, there are a few of you that if I had my choice, I would have already exempt you from the final, but they don't like us to exempt people from finals anymore. So, that's the way it is. Okay, well, I think it would be wise then to just do a test that covers everything. That way you can do stuff that might be easy to you, like plugging things into functions, evaluating a function, finding a domain, finding the equation of a line. So with that said, what I'll do is I'm going to cover today's new material, which will be pretty brief. It should only take us about half an hour, 45 minutes. And then after that, start going through this review. Sound fair? All right, so let's start with today's material. And what I'll do is I'll start with the number 15 on the review. So you're asked to solve a system of equations so let's see who watched the video. If you're going to solve a system of equations like that, what should you do first?
Find the simplest one to solve.
Find the simplest one to solve. So you get to pick a variable.
Yes.
You get to pick which one, and then you get to solve for it. So do any of those look like they're easy to solve for? Top equation, which variable? The y, right? Because it doesn't have a number in front of it. So that looks like it would be the easiest one to solve for. Now what if they all had numbers in front of them? You just got to pick one, right? And sometimes that's just a crapshoot. You know, you just try something and just see where it goes. So I'm going to take the first equation, and I'm going to solve it for y. That means all I have to do is isolate y. So I will, what? Add 3x to both sides of the equation. You get y equals, I'll put over here 3x plus 10. Okay, now I know what y is. Y is actually 3x plus 10. So if I know what x is, then I can go back and get y, can't I? All right, now how do we figure out what x is? Plug that into the other equation that you didn't use, right, for y. So I'm going to go to the second equation, which I'll write right here, 2x minus 3y equals negative 9. I'm going to replace the y with this right here. So that equation becomes 2x minus 3 times 3x plus 10 equals negative 9. Also notice the use of parentheses, right? That negative 3 is in front of y, multiplies times whatever y is. So if y is 2 things, then negative 3 must distribute through. So let's go ahead and distribute that through. My next line should read 2x minus 9x minus 30, right? Equals negative 9. So 2x minus 9x minus 30 equals negative 9. Now this equation has just x in it, so we solve for x. So how many x's do I have there total? Those two together, negative 7, right? Over here, minus 30 equals negative 9. Now what? Add 30 to both sides. When I add 30 on the left, it goes away. When I add 30 on the right, I get what? 21. So negative 7x equals 21. Divide through by negative 7. Divide through by negative 7. Not subtract, not add. You get x is negative 3. Am I done?
No.
No, now I need to go get y, right? But I know what x is. So I come back to this equation that I boxed. I replace x with -3. And what would that give you?
1.
1. Y is 1. So in order for both equations that I started with to be true, you could let x be -3 and you could let y be 1, and both would be true at the same time. Right? So our answer, you want to look at it as a final answer, it's these two right here, right? You could write it like that, or you could also write it, I wouldn't mind if you wrote it like this too, like a point x, y, you could do it that way also. Questions? All right, so let's see if we can do some sort of application problem, like how you could apply this to something. You have the general idea of how to solve a system, right? All right, let me start out with a problem that most people can follow pretty easily. Try and use some numbers here that will work. Jill is 4 years older than Jack. Jill's age plus Jack's age plus, let's say plus twice Jack's age is hold on a second, thinking through this. What's that? I'm going to make up a number here. We'll see what their ages come out to. 64. All right, so what's the question going to be? Okay, well, what am I going to ask for in the question? I've just told you about Jill and Jack, but what am I going to ask for? How old are they? Right? That's the question. How old are they? So how old are Jack and Jill? So what we're going to do is we're going to come up and try and set up some equations. Let's say, what are we trying to find? We're trying to find Jill's age and Jack's age, right? So I'm going to let x be Jill's age. I'm going to let y be Jack's age. Right? If x is Jill's age and y is Jack's age, what does the first sentence tell us? Jill's age, right, is 4 years, or Jill is 4 years older than Jack. So whatever Jack is, right, Jill is what?
4 years old.
4 years older than that. How can I translate that into an equation? X equals y plus 4. Let me write it down. Tell me if you agree. X is Jill's age, right? Is Jill's age equal to Jack's age? Not just Jack's age, right, by itself. It's Jack's age plus 4 because she's 4 years older than he is. Do you all agree with that?
Yeah.
Okay, you have to make that translation. You have to actually turn the sentence into the equation. It's part of your challenge. Okay, so that's the first equation. What's the next equation? Jill's age plus twice Jack's age. How could I write that? Jill's age is what? Plus twice Jack's age, 2y is what? 64. Do you have two equations? Yes. So this is a system of equations, isn't it? What's the first step for solving a system of equations? Pick one of the variables and solve for it, right? But it's already done, right? I mean, we already have the first equation solved for x, don't we? So I don't even have to do that step. All I have to write is x equals y plus 4. I know that from the first equation. Now I move on, I try and use the other equation to get what y is. So I'm going to go to the second equation. I'm going to replace x in this equation with y plus 4. So I'm writing down the second equation. I'm going to replace x with what? This is going to replace y plus 4. So y plus 4 plus 2y equals what? 64. Now, on the left side, we have 3 y's plus 4 equals 64. 64. Then you can get your y by itself, 3y by itself by subtracting 4 on both sides. So 3y equals 60. Yes? Divide by 3. So y is what? 20. If y is 20, can you tell me what x is? 24, right? Come over here, plug in 20 right here, and add 4, so x is 24. So let's just check it. X was Jill, right? Y was Jack. The first sentence said that Jill is 4 years older than Jack. Is that true?
Yes.
Yes? Second one says that Jill's age added to twice Jack's age should be 64. So what's twice Jack's age? 40 plus 24? 64. That's it.
The whole final can be that way.
You like this? The whole idea is just that if you have two equations and two variables, x and y, normally we can solve for both of them. To figure out two variables, you need 2 equations. To figure out 3 variables, you need 3 equations. 4 equations, so on and so forth. So let's see if I can get your brain wrapped around the next problem I'm going to do. All right. All right. Let's say that I have a container of just pure water. Okay. Let's say this container has water in it, H2O. All right. There's water in there. And let's just say for this example that that's a 10-gallon drum of water. Well, there's 10 gallons of water in it. The drum holds more, but there's 10 gallons of water in there. All right? And let's say that that gallon, or the water in there has, you didn't notice, but I had mixed sugar in there to make, I'm going to make tea eventually or something, so I'm making sugar water. So of that 10 gallons, sitting in here is 1 gallon of sugar. That's some sweet stuff right there. All right? So 10 gallons total, right? 1 gallon of sugar. So wouldn't that mean you would have 9 gallons of water? Like pure water, if you were to separate it from the sugar. You have 9 gallons of water, 1 gallon of sugar. Guys, I mean, if you're distracting me, there's 2 people behind you trying to watch me, and they're just watching you guys have a little comic festival there. All right? All right. 9 gallons of water here, right? So 9 gallons of water mixed with your 10 gallons of sugar together makes 10 gallons total of sugar water. Yes? Now you stir it up and you can't tell where the water and sugar is, right? It's just all mixed together. All right. Make sense? So what we would say in this particular case is that this is a 10% sugar solution. What do I mean by that? Well, how much total is there in there? How much total everything? How many gallons? There's 10 gallons total, right? How much of it is sugar? 1 gallon. If I take 1 and divide it by sugar, right, if I take 1 gallon of sugar divided by 10, that's a ratio, then you get 0.1, don't you? 0.1 converted to a percentage is 10%. So this is a 10% solution of sugar. You could also say it's a 90% solution of what? Water. But do you understand how this percentage is obtained? Okay. So you tell me this. Let's say I take a mixture and I do, there's 7 gallons water, 3 gallons sugar. What percentage mixture of that is sugar? So what are your total gallons together? 10 again, right? 10 again total. So how much of it is sugar? 3 out of 10, right? Which is 0.3, which would be a 30% sugar solution. Understand? Give you another one. What if I have a solution? I have, let's say, 22 gallons. I won't say gallons. I'll just put, let's just assume it's gallons. We have 22 gallons of water. We have 3 gallons of sugar. What is your percentage solution of sugar? What is it? 12? How are you getting 12? How did we get 3 out of 10 here? We said, well, how much total was there? How many gallons total were there? 10, right? How many of those were sugar? 3. Well, how many gallons total do you have here? 25. How many of them are sugar? 3. What's 3 divided by 25? So you need your calculator for that. Well, maybe not, but what is it? 12. So, well, you get 0.12, right? Which is 12%. Is that okay? All right. Now, let me get to what we're trying to do. I'm going to look at the problem on here now. You wish to create an 18-gallon mixture of 14% alcohol. Now, if the alcohol thing is confusing you, replace the word alcohol in this entire problem with sugar, all right? But you're trying to make an 18-gallon mixture of 14% alcohol by mixing a 30% alcohol mixture with a 5% alcohol mixture. How much of each is required? So let me try and give you a visual of what's happening here. Anybody here ever worked in a chemistry lab, like as a student or something? You've been in a chem lab? No? A few of you? Okay. If you ever have, if you're trying to do a certain solution, usually in the back somewhere they've got these chemicals pre-made. And so in this particular situation, we have a 30% mixture of alcohol, and we have a 5% mixture of alcohol on hand in the back somewhere, okay, that we have as much of this as we need, okay? And what I need to make, we need to somehow mix these, right, to create 18 gallons. I'll just put G, okay? 18 gallons, but this needs to be a 14% mixture. So let's try and understand how this is working. If I took 30% solution, could I water that down and make it a 14%? I could, right? But the problem with that is what it takes to make that 14% may not turn out to be 18 gallons at the end. Yes? Now with this one, 5%, I can't make it 14% unless I add more sugar or alcohol to it, right? But again, if I add more sugar or alcohol, I may not have 18 gallons at the end. So the idea in a chemistry lab is that you take both, since this is more than 14, this is less than 14, is to mix them in a certain way, like maybe I need a little more of the 30, and a little bit of the 5, and a little more of 30, until I get it exactly 14% and exactly 18 gallons. So I want to mix it just right so that that all works out. Does that make sense? So let's talk about what we're going to do here. We are going to take the 30% and we're going to pour some amount of it in, right? And then we're going to take the 5%, we're going to pour some amount of that in. The question is how much of each, right? So let's let X be equal to the number of gallons of the 30% mixture. Okay? That's the X, what I'm trying to figure out is how much of the 30% do I put in? And then the Y should be the number of gallons of the 5%, right? That's all you have to tell me to answer the question, right? Just tell me what each one needs to be. Is there anything you know right off the bat? The total number of gallons, right? We know that we need 18 gallons total at the end. So I know that how many gallons of X I put in plus how many gallons of Y I put in has to add up to be what? 18. So that's my first equation, isn't it? Okay, so I'm going to put that here. I know right now, just from this, that X plus Y has to be 18. Now what? So let me step away from the problem to help you see this a little bit better. This might be easier for you to see. Come back to this. Let's say I had 10 gallons here, right? Let's say it was 10%. Well, I'll make it. Let's say it was 50% sugar in here. If I had 10 gallons of 50% sugar, how much sugar would I have? 5 gallons, right? Agreed? This would be 5 gallons sugar. What if I had 8 gallons and I told you that that was a 30% mixture? How much sugar would be there? So here's 8 gallons of this mixture, 30% of it is sugar. So what would that be? How would you figure that out? You do 8 times what? 0.3. 0.3 is 30%, right? What's 8 times 0.3? 2.4? So if you have 8 gallons of something, 30% of it's sugar, that means you have 2.4 gallons of it is sugar. Look, you did the same thing here, even though you didn't, you probably just thought it, like mentally you did it. But 10 times 0.5, right? 10 times 0.5 is 5. Yeah? If I have 300 gallons here, and I tell you it's a 5% mixture, how much of it is sugar? So what computation will you do? 300 times what? 0.05. And what's that? 15? Y'all understand how this is working? Whatever the amount you have there times whatever the percentage is gives you how much of that you have in there, how much sugar you would have. So going back to our problem, our final mixture needs to be how many gallons? 18 gallons. What does our concentration need to be? We want it to be 14%, right? So my first equation I've already done, right? That's sitting there tucked away, ready for us to work with. My next equation is all about the sugar, or the alcohol. How much alcohol is in this? How much alcohol would be in this mixture right here? If I have 18 gallons and it's supposed to be 14% concentration, I do 18 times 0.14, and what would I have? 2 point what? 52? 2.52. All right? That's how much alcohol I want there at the end, don't I? So the way I'm going to use this is as follows. When I pour in, I had a 30%, right? I had that 30%, and I poured it in. How much of it did I pour in? I don't know yet, right? So I call it X. So how much alcohol or sugar would come out of this? How did we do this? If we know this is the percentage and this is how much was there, we multiplied the two together and got this, right? That's how much should be there at the end. When I pour the 30% in, how much alcohol or sugar will I have here? I don't know exactly, but I can represent it with my letters, can't I? It's 0.3x, isn't it? 0.3x. Do you all agree with that? 0.3x. That's 30% times x. So that's how much sugar I get from pouring that one in. Now when I pour the other one in, that was a 5% mixture? How much of it did I pour in? 0.05, but how much of it did I actually pour? I don't know, right? Why? So how much would be there? 0.05 y. So this is how much sugar will be there if I pour in x. This is how much sugar will be there if I pour in y, right? Those two have to add up to be what? Oh, careful. The amount of sugar I have at the end. 2.52. Yes? I'll try and do it with a different sort of picture, all right? This kind of gives it to you, but let me... Right. Okay. The equation x plus y equals 18 came from the fact that we were going to pour in x gallons, right, plus the y gallons, and that at the end had to be equal to 18 gallons, right? That was the first thing. The second piece of information, the second equation, comes from the fact that this 30% mixture had x plus the 5% mixture at y must equal my what? 18-gallon mixture at 14%. Do you see the difference between the two equations? One of them is dealing with just how much is actually there. The other one is how much sugar is actually there, or how much alcohol is actually there. Yes? So converting this one over, what does that turn into as an equation? We said the first one was 0.3x plus 0.05y must be 2.52. And that's my second equation. So I have my two equations. Now I go solve. All right? Any questions? So here's my system of equations. It's not as nice as what we've seen before. We have that. We have 0.3x plus 0.05y equals 2.52. Now let me give you a tip for this, because on your final, if you get a problem like this, which you will get a problem like this, you're going to have decimals, right? And people don't like working with decimals, just like they don't like working with fractions. So what we can do is we can clear the decimals. And the rule is that if you want to move the decimal point over, you can move it over one spot, but you have to move every one of them over one spot. All right? So if I move this 0.3, move it over one spot, it'll become a 3x, right? Move this one over one spot, it'll become a what? 0.5y, and move one spot here, we got 25.2. So you still have decimals, don't you? So instead of going one spot, why don't we go two? So if I move this over two spots, that 0.3 becomes a what? 30. This one becomes 5y, and this one becomes 252. So that's the first thing I'm going to do. I'm going to rewrite everything. This becomes 30x plus 5y equals 252. Now you don't have to worry about the decimals so much. We clear? Solve one of these equations for one of the variables. So what do you think? First equation? X or y? It really doesn't matter, right? They're both equally as good. So x, y? X? Okay. So I'm going to solve the first equation for x, which means all I'm going to do is take y to the other side. I can write it as negative y plus 18, or I could write it as 18 minus y. They mean the same thing. So that's my first equation, or my first equation solved for a variable. Now I'm going to take that and plug it in for x into the other equation. So it becomes 30 times x, but x is negative y plus 18, then plus 5y, and then equals 252. Distribute 30 through, and you get negative 30y. What's this? Plus 540. Then plus 5y equals 252. Put your y's together. How many y's will I have if I put those together over there? Negative 25. And then let's go ahead and take the 540 to the other side by subtracting it. So if I subtract 540 on both sides, what will I have? Negative 288. Do you all agree? Now divide through by negative 25, and what do you have? What is it? 11.52. If I know what y is, I can go back and get x, can't I? So to get x, I plug in here. X is equal to negative y, but we just found out what y was. So negative 11.52 plus 18. So what would that be? $6.48. That's it. We're done. What does it mean? I'm going to take the 30% mixture, right? The 30% mixture. I'm going to pour in exactly how much of the 30%. Shit, hurry. I already poured it all out. How much did I pour in? 6.48 gallons, right, of the 30%. I'm going to take 11.52 gallons of the 5%, mix it up. I'll have exactly 18 gallons. It should be a 14% mixture. You can do anything like this. That's why, you have different grades of, there's a lot of different things you can think of, like gasoline. You have different grades and the way they mix things. They usually have certain mixtures always on hand. And then if they want to make something in between, they just mix them properly and they create what they want. System of equations. What did I tell you all about number 16 on the review? Did I tell you all anything about that? The ball is being thrown upward, up from a bridge. Did I tell you all anything about that? How high does the ball go? How long does it take the ball to hit the ground? Is that something we're interested in? I know you're not interested. Okay, so I want you to be able to do all three of these. Well, these three problems on the back, 15, 16, 17, I would like for everyone here to be able to do those. So I want to talk about this ball problem. It's not going to be as bad as it may look because it goes off of something we've already done. All right, we just didn't have time when we were talking about it to cover it. So this will be still new material today. Do you all remember this? Or maybe if that doesn't ring a bell, this will. Those are both examples of what? What do we call these? Grafting, vertex. These are both examples of parabolas, quadratic functions, right? You remember that? Quadratic functions, you had to sketch them by hand, you had to find the vertexes that open up or down, all that stuff, right? And depending on the form that you had, you went about it in two different ways. Okay? This one right here is the one I want you to focus your attention on. If you have a function where you have a number in front of the variable squared plus a number in front of the variable plus a number by itself, that is a quadratic. And therefore, it has to look like one of two things. It has to look like this, or it has to look like this, right? Both of these actually do, but remember, this turns into one of those graphs. All right, now, with that in mind, let's think about a ball being thrown through the air. And I kind of alluded to this when we were covering quadratics. I said, why are these useful? And I said, if you throw something through the air. Y'all remember me throwing the markers through the air? Yes? Okay. So let's say that you have someone and they're standing on a building and they want to throw something off the building. Okay, so they throw something, it travels like this and it comes down and hits the ground like that, right? Well, that little part of this graph, if you look at it as a graph, is actually just part of a parabola, right? This would be the x-intercept. The top of this would be your vertex, right, HK? So if you know the actual function, right, if I give you what that function is, you should be able to tell me how high and how low it, or in this case, how high it went, right? You'd be able to tell me how high it went? What would be the height of this ball if it were thrown? What is that? In terms of this picture, what's this value and what's this value? How could you get to that point? You'd have to go out how much? Up how much? H and K, right? Okay, maybe I was being too tricky. H is how far out you were, right? K is how far up you were. So if I ask you, hey, how high did that ball go? All you'd have to do is find K, right? If I tell you, hey, how long did it take for it to reach the highest point? Then you just tell me what H is, because H is going to be more like the time, or the distance out. Okay? Now, what if I throw a ball, but I throw it harder, so it goes up higher and then comes back down, right? Something like that. That's a different parabola, right? Totally different function. Or if I throw it more, straight out like this, it will go like that. But that's still a parabola, right? It just looks like it's narrowed out. What if I throw it straight out? If I throw it straight out, what happens as soon as I throw it straight out? What starts happening to the ball? It starts falling, right? So it would actually go like this, right? So wouldn't the vertex be where I let it go? If I threw it straight out? Yeah? All of these are parabolas. They all have different functions, right, that determine where you are. Well, it was studied by scientists and determined that there is one function that a general function that describes all objects on Earth in the way they fly through the air. And it is this function. It's d of t. Now I'm going to use d instead of f of x. I'm going to use t instead of x because t is going to be like time. This is negative 16 t squared plus v with a little 0. I'll tell you what that means, t, plus d, a little 0 here. I'll tell you what that means. But what I'd like for you to see in this formula is this. This is really f of x equals ax squared plus bx plus c. That's really just a quadratic. In this case, a is always what? Negative 16. B we've replaced with this weird thing that we call v naught. And then, the x is t. And then the c we replace with this thing called d naught. And now what I'm going to do is I'm going to explain what all of these things mean, all these little v naughts, t and d and all this stuff, and give you our general formula for objects falling on Earth. All right? So t here, of course, is going to be time, and it's measured in seconds. Let me give you the formula first, then I'll show you how we use it. So t is time. D naught is your starting height. And it's always measured in feet for this formula. V naught, anyone know what that's? So you're starting something. V is going to stand for velocity. Okay? Velocity or speed. And this is measured in feet per second. And I'm going to say if it's up means it's a positive number. Down means it's a negative number. Again, you'll have to let me go through some examples of this. So we have starting velocity. Now we know what t is, we know what d naught is. So what does the function give you? What is d of t mean? D of t is going to be the height of the object at time t. So let me try and get our heads around how powerful this formula is, because it is a very powerful formula. It's saying that if I have an object on Earth, okay, on Earth, this formula only works on Earth, that if I'm going to either throw it up a little bit, or throw it straight out, or throw it down, no matter what I do, the height of the object off the ground after a certain amount of time always has to follow this formula. Always. So let's just try it. Let's say I'm about to throw this object. So my time right now is what?
0.
0, right? Plug 0 into this, and what do you get? Plug 0 in for t, and what do you get? What do you get? 0, 0, d naught. What's d naught? My starting height. So I'm about to start my watch. I'm going to let it go. D naught should be how high it is off the ground to start, right? And then I throw it, right? The clock starts ticking. If I stop it at some point in time, t equals 1. Whatever that value is now the height of the ball, or whatever it is I'm throwing. And then at some point in time, it eventually hits the ground. When it hits the ground, right, you now are at an x-intercept. You're trying to figure out when this function is 0. What's the highest point? Well, because it's quadratic, it would be the vertex. Understand? My question to you would be, there's a couple questions I would like to ask you. If I just drop two objects on Earth, are they going to always drop the same? Like, will they always hit the ground at the same time? If I drop two markers, they hit pretty much the same time, right? Well, what if I get my marker and borrow your cell phone? My marker and my keys, right? And I drop those. They kind of seem to hit the ground at the same time, right? So do all objects hit the ground same time on Earth? Like, does it matter what object it is? No? Okay, yeah, so what if I take my book and my review and I drop those? So what hits the ground first? The book, right? Almost got it. Now, what is it that made the book hit the ground before the paper? Is it because the book is heavier than the paper? Or is it just something else? The mass? Surface area? Okay. There's a lot of different answers to that question, but it is not because it's heavier. Okay? Heavier objects do not fall faster on Earth. All objects on Earth will fall at the same rate regardless of how much they weigh, regardless of their mass. The only thing slowing this paper down is air. If there was not air in this room, then these would fall together. And to prove it to you, so I'll ask this question. This is a question you don't have to answer me. If you think it's because this is heavier, then if I put this paper on top of the book and I let them go, and you think the book falls faster because it's heavier, then what should happen is the book should start falling faster and the paper should not fall as fast, right? Yes? If you think it's because it's heavier? There's no tape up here. There's no glue. Okay? Watch. So they go together. The reason why is the book moves the air out of the way, so the paper no longer has air resistance, so they go together, right? So how many of you have ever seen that video, old school video of the guy, like the astronaut on the moon, and he's like bouncing like this, and he's got a hammer and a feather? You ever seen that? The astronaut on the moon, one of the things that we did when we got up there is they took a hammer and a feather, and they dropped them, and they both right to the ground at the same time. That's because on the moon there is no atmosphere, there is no air to slow the feather down. So it was kind of like they did that, just kind of, they already knew it was true, okay? That if there was no air, they knew things would go together. But it was kind of just that kind of last little to you, to all the people who didn't believe them, you know, there it is. You see it? They fell. So what I need to add to this formula before we go on with it is that this formula works for all objects on Earth because all objects on Earth fall at the same rate. The only problem with this formula is that it assumes that there's no air. Well, that's kind of sucks, right? Because there is air. So what happens if you now let air be in there? Does this formula change? Yes, it becomes much more complicated. But you have to start somewhere. It's kind of like baby steps. We say, okay, this is the formula that governs what happens when there's no air. If you want to add air, you add something that's going to become more complicated, and that's what you do in physics classes. You start out, anyone ever here taking a physics class? You start out, and it's like, let's assume we're moving this object with no friction. And then later on, you say, okay, well, now add friction. Okay, now let it spin. You know, so you start and you build up. All right, so there's the formula, right? I know you want to see it in action, but I want to ask you one more thing. Maybe two more things. If I take this marker and I drop them together, we already said they would hit the ground at the same time, right? Now, what if I take this marker and I throw it straight out as hard as I can and drop this one straight down? So I'm going to try and throw this one straight out and drop this one straight down all at the same time. Which one will hit the ground first? Same? I think if I throw that one outward and let this one go, they'll hit the ground at the same time? Or you think that I throw out will hit? So I'll try and do it. I don't know how this is going to work, but well, they will hit the ground at the same time. And the reason why is because as this one moves to the side, the only force acting on it is gravity. And when this one is let go, the only force acting is gravity, so they both come together and they hit at the same time. It does not matter if it's moving left and right. It does not change anything. They both hit the ground at the same time. Now that's what snipers have to deal with. Any military people here? I've had a couple of snipers in my classes in the past. And that they have to account for the drop of the bullet, they have to account for wind and all that other stuff. But so last thing, I promise. If I take a bullet and I fire a bullet out of a gun, there's a bullet coming out this way, all right? it starts to drop like a parabola, doesn't it? So let's say here's the ground. If I fire it pretty fast, it'll eventually hit the ground there. If I fire it out of that gun faster, it'll go further, but it'll still eventually hit the ground, right? If I fire it even faster, it'll eventually hit the ground. Well, if you fire it fast enough, okay, if you can get it going fast enough, then what happens is that as it goes, and it's always dropping, right? It's always dropping. But as it drops, if it's fast enough coming out of the gun, then remember the Earth's round, right? What will happen is the Earth is eventually going to curve because the Earth is curving. It's round. It's a round planet, right? So if you fire it fast enough, what happens is as it falls, the Earth starts to fall away from it. So what happens is it keeps on trying to fall towards the Earth, but the Earth keeps curving. And so it gets stuck in this perpetual falling motion. And you get this thing trying to fall towards the Earth, and the Earth is still curved away. You understand? And that's what orbit is. That's when you see the moon going around the Earth, right? When you see these satellites going around the Earth. They don't have their engines on. The satellites aren't sitting there, firing away trying to go around the Earth. They just are up there. They get them out there. And as soon as they get them into the right speed and the right distance off the ground, they say, okay, this is it. Let it go. Turn off all the engines. And now it'll start falling towards the Earth. But the Earth is going to curve away. And it just keeps on being stuck in a perpetual orbit. Make sense? So getting out that fast is the challenge. Getting it to go fast enough. Which is why you have to put it on a rocket. Fire it out. All right, let's see this formula in action since I put half of you to sleep. And the other half are daydreaming about the summer vacation that's left. All right, let's see this formula in action. So let's take a look at this problem on the review. A ball is thrown upward from a 30-foot bridge. So let's say I have a bridge. I'll look at the bridge from the side, like someone's standing here, right? They're going to throw this ball upward with a speed of 40 feet per second. So they're just kind of like throwing this ball up and out, and then it comes back down and hits the ground. Now, how high was it when it started? 30 feet. And we'll assume that, let's not take into account how tall the person was or anything. Let's just say the ball left the ground 30 feet, right? It was thrown upward with a speed of 40 feet per second. That means that as I throw it out, it was going up with a certain speed when it started, 40 feet per second. So it's going to go out and up and eventually come back down. How high does the ball go? How long does it take the ball to hit the ground? Those are the two questions. So all you have to do is, from this information, figure out what gets plugged in here and then solve the question, solve the problem. So what is the 30 feet for us? D naught. That's where it started from, right? That's 30. And then what is V naught? That's our starting velocity, right? 40 feet per second. So we'll just put a 40 here. We'll put a 30 here. Now when I put 40 here, do I put positive or negative 40? Well, look back at what I wrote up here a second ago. Said if it's going up, you put a positive. If it's down, then it's negative. Think about it this way. If I throw a ball up, right, it's going to take longer for it to come down. So adding a plus here is going to increase it. If I throw it downward, it's there, right? I help to get down there faster. So we put a negative to decrease it faster. What do you think the negative 16 is? Because you don't ever mess with that. That number you always leave is negative 16. That's the acceleration of gravity. So if you're on the moon, the only thing that changes when you're on the moon for this equation is that changes because the gravity is different on the moon. And if you go to a different planet, that changes. All right? All right, let's write down. Oh, I think I killed this one. Let's mark down the equation we have, the function. It's negative 16 t squared plus 40t plus 30. Right? That's what I'm working with here. How high does the ball go? So what did we say we wanted to get? We have a parabola, the height, right? The height of the parabola would be what? HK, which one of those is it? The height? K, right? So I need to get K from that. So I need the vertex, right? To get K, you have to know what H is. Do you remember how to get vertex of the parabola? There was a formula for it. H was negative b over 2a, remember that one? And then f of h was k. So k is what we get when we take that and we plug it into the function. So you have to go back. So for us, what is h in this problem? What is h? Negative b, so b is 40, so h for us is negative 40 over 2 times what's a? Negative 16. This is going to be a decimal. This is negative 40 over negative 32. On your calculator, what do you get? Approximately 1.25? Approximately 1.25. That's your h. Now to get k, what we're going to do is we're going to plug that into the function. So I'm not going to use f, I'm going to use d, because remember the name of the function is d. So d of 1.25. And that means on my calculator I'm going to have to figure out what negative 16 times 1.25 squared is, plus 40 times 1.25 plus 30. And it's going to be important that I do the correct operation order here. Square the 1.25, then times negative 16. See if you can get that. Anyone get something yet?
55.
We got 55?
Yeah.
Anyone else? 55? Yeah? 55? Approximately 55. What was it that we were trying to find? This is our K, right? So what does that number represent? The what? This was H. K is 55. What does that mean in terms of our word problem? That's the highest point, right? That's the maximum height of that ball. That's the highest it will go. So if you take a ball from a 30-foot bridge and you throw it out of your arm with the speed going up at 40 feet per second, the highest it's ever going to get is 55 feet. Then it's going to start coming back down. Okay? Now, how do we find the when it hits the ground? How long does it take to hit the ground? So what does that correspond to in our picture? Right here, right? Don't we want to know how long is time? When the distance is what? When you hit the ground, what's your distance off the ground? Your x-intercept, so your distance is 0, right? So you want to know when this whole thing is equal to 0. Don't you? And you solve that equation. So for the next part, what I'll do is I'll take negative 16t squared plus 40t plus 30, and I will set that to 0. How would you solve that? What are your options? You try and factor it, right? Synthetic, quadratic formula, right? All these different options to do that. But you should get 2 answers, right? What I'm going to do is quadratic formula. T will be equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. That look familiar? I'm using t instead of x because our variable is t. Negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. and then I'll let you figure out what that would be. One of the answers will be negative, which means you throw it out. The other answer is positive. I'll solve it right here. I'm getting 3.1 and negative 0.6. Those are the two answers you should get. But only one of these makes sense, right? How much time, how long does it take to hit the ground? Not negative, right? Positive what? 3.1 seconds. Why is it seconds? Remember I said everything in the problem is measured, feet, time was measured in seconds? So if you throw this ball, it takes 3.1 seconds for it to hit the ground. Just out of curiosity, if your formula, your general formula is V naught, D naught, what if I tell you you have an object that's 30 feet off the ground and you just let it go? You don't throw it up, you don't throw it down, you just let it go. Then what's your starting velocity? 0. So that would just kill this term off completely. So if you just drop an object, your starting velocity is 0. Throw it up, then you have to account for it. All right, well, shall we take a little break?
Is it different from different countries, or the meters?
Oh yeah, the equation would change if you were doing, if you wanted to go, instead of feet, you want to go meters. Then that would change like negative 9.8. You would use the acceleration of gravity that most people know from physics classes. That's it.
Trying to get my mind off.
My wife was addicted to that for a while.
And then you get stuck.
Well, what happened? She got a new phone, and she couldn't bring over her where she was in the game, unless she did it through her Facebook account, and she doesn't want that crap. Yeah.
I was gonna say.
You all seem like y'all are done, like just done. Is that a correct interpretation for what I'm seeing on this end? Are y'all ready to be done? What do y'all think about this format of the final? If I stick with something like this, like where the first section you chose 3 of those 5 problems to do, then choose 2 of the 3. Who doesn't have one of these with them right now? Anyone not have it? You want to look at it so you know what I'm talking about? What do y'all think of that format? It kind of really allows you to pick the problems you're comfortable with. No. But that's a great question. Did everyone hear the question? Do you get extra credit if you do them all? No. In fact, you cannot, if I say do 3 and you do 4 because you're like just not sure about one, I'll take your worst 3. I won't take your best 3. All right? Because look, the idea is this. The test is designed to give you options, but that means you have to choose. That's the pro and the con. You have to choose rather than having to do them all no matter what. Does that sound fair? All right. Okay, so look, the first one, do any of these 3. First problem, graph a line. Second problem, 2 domain problems. Third one, evaluate a function. Fourth one, composition. Fifth one, sketch the line. So let's knock those out real quick. Yes? See how quickly I can do these. Would you like me to make up my own and leave this for you? Or just do them? Just do them? Do them? All right. So find the equation of the line in slope-intercept form of the line which is perpendicular to 5x minus 2y equals 12, but passes through this point, negative 3, 2. So my final answer, I want the line in slope-intercept form. I'm going to move fast here, okay? I'm going to move quick. All right, we want to be perpendicular to that line. That means we need to solve it for y. We need to divide through by negative 2. So I divided everything by negative 2. And then I identify what the slope of this line is. What's the slope of that line? You don't need the negatives, right? Slope of that line is 5 over 2. The line I'm looking for needs to be perpendicular to this line. So the slope of my line needs to be what? Negative 2 over 5, reciprocal of that. So here's the point that I have for my line. The slope for my line that I'm trying to find is negative 2 over 5. Once you have a point and once you have a slope, you can find the equation of your line. And there were two formulas I gave you, weren't there? Point slope formula, and then you can just use y equals mx plus b. So this is what we have. Y equals m, which was negative 2 over 5x plus b. I think this is the way that everyone liked to do it. This is our equation, but we just need to find one more thing, and that's b. So how do we find b? Remember how we do that? You plug in x here, negative 3, plug in y here, 2, and solve for b. So y is 2, negative 2 over 5, x was negative 3, and then you solve for b. I'm going to let you do the rest. Right. Just multiply here, then move it to the other side. You know what b is. Come take that answer, plug it back in here, and then that will be your equation. Do you remember any of that as a couple of weeks ago? Like 7 weeks ago. All right, number 2. These are more straightforward. Number 2a, find the domain. Domain, what's the issue with that f of x for part A? What could possibly happen that wouldn't be good? The denominator could be 0, right? I don't want that, right? I don't want the denominator to be 0. So I'm going to try and figure out when it's 0. So I'm going to take the left side, I'm going to factor an x out. I don't want that to be 0. Why don't I want that to be 0? Why don't I want that to be 0? What if I had, that's the denominator, right? If that's 0, you have division by 0 is not allowed. Right? That's why I'm looking at this. Can I do anything else to that? Different squares. So I don't want any of those factors to be 0. So what are the 3 things that it can't be? X can't be 0. X can't be negative 5. X can't be 5. Now, is that the way that we wrote answers in here for these domain problems? We did interval form, right? We did the interval notation. So this is everything except those numbers. So here's the way it would be on a number line. I don't want negative 5. I don't want 0. I don't want 5. I want everything to the left, everything in between, everything to the right. So how do I say that? Negative infinity to negative 5, but then unioned. Negative 5 to 0, but then unioned. 0 to 5, but then unioned. 5 to infinity. So I have, it was like 4 sections, right? This one, this one, this one, this one. What about 2b? Remember when you have a square root, what's underneath the square root, which we call the radicand, cannot be negative, right? So I need to make sure that that is greater than, and it could be 0. It's okay to take the square root of 0. So this has to be greater than or equal to 0. So add 2x to both sides. Divide by 2. And you get x is less than or equal to 15, or you can say 15 is greater than or equal to x. So here's 15. Our x is smaller than or equal to 15, which is this way. I do include 15, right? So we said you could do it like that. So what's the interval? How do I say that? Everything to the left of 15, including 15. Negative infinity to 15, and then bracket. So that's what I'd be looking for there. Number 3. 3a. For 3a, I want f of negative 2t. So you're going to plug into here negative 2t squared minus 3 times negative 2t plus 7. So all I'm doing is I'm going to the function that's given. I'm replacing all my x's with negative 2t. And then just evaluate. So you square this. What happens when you square that? What do you get? 4t squared? Because negative times negative is positive. So 4t squared. But then you make the whole thing negative again. So negative 4t squared. What do you get here? Plus 6t. Then plus 7. That's part A. Part B, it's the same thing except what you're plugging in is different, right? This one can be a little bit tricky. You have negative, you're plugging in 3v plus 1 squared minus 3 times 3v plus 1, and then plus 7. Make sure the 3v plus 1 is in parentheses. You'll distribute that, right? What do you have to do with this? FOIL it. 3v plus 1 times 3v plus 1. When you do that, you get 9v squared plus 6v plus 1. And then what would you do with the negative? Pass it through all those, right? I know I'm working through this fast, but let me write down the next line. You'll have this, but change the signs. Negative 9v squared minus 6v minus 1. Then you come in here and do this. Negative 9v minus 3, then plus 7. And then just combine all your terms together, your like terms. Negative 9v squared minus 15v. And then, what's that, plus 3? Follow? Number 4. Find and simplify f of g of x and g of f of x. So fog and golf. So for 4a, I'm going to take f of g of x, which means you take f and inside of it you plug in g. But what's g in this problem? 2x plus 3. That gets plugged into f, but what's f? It's 3x squared, so I'm going to take all those x's and replace them with the 2x plus 3. Now I'm not going to work this one out, okay, but you would distribute the negative 2 through. You would do FOIL on that like we did up there, and then distribute a 3 through, and then collect all your like terms and be done. That's fog. Goth is, or g of f of x, would be the opposite way. You take g, inside goes f. But f is 3x squared minus 2x plus 4. So into g, this one's easier. G is just 2x plus 3. So this is 2 times x plus 3. What goes in here for x? That whole thing, right? So this whole thing goes in here. And then you distribute your 2 through. Have y'all noticed that all these problems are not equally weighted? Like, when you do numbers 1 through 5, you pick 3 of those, right? 3 of them, 3 5-point problems is 15 points. But look at the next one. Do 2 of these, and how much are those worth? 10, 10, 16, and 16. So if you start adding up the points on this thing, the most you can get from the first 5 is 15. What's the most you can get from 6, 7, and 8? You could get 32 points. Yes.
What if we do the entire task?
You're not allowed to.
Oh.
That's what I was saying a little louder. Yeah. You can only do what I ask. Yeah. If you do more, then I'll take your worst ones. That's what I was saying.
Okay, yeah.
So I'll have to go through and look at the totals, but I believe there's a way to get more than 100 on this. Out of 100. So there's a way, there's like a built-in bonus. If you do the harder problems, you can get higher grade. Let's see, let's just check real quick. The first section, you can get 15 points total, right? The second section, the most you can get was 32. And then the next one, you have to do those, that's 10. 11 through 14, you can do any 3. So what's the most you can get there? 20? Last one, do any 2. 20, 34. So what is that? What is it? 111? So you could actually get 111 on this test if you did all the highest value problems. Make sense? That's 111 out of 100, so yes, that is bonus. It's built in. Okay, how about number 5? Sketch the line. You have options for this one. There were basically 2 methods that we used to sketch lines. One was the intercept method, one was the slope intercept method. So intercept method meant we go find the x-intercepts. How do you find x-intercepts? You set y equal to 0. If I set y equal to 0, I get 2x equals 10. If I solve for x, I get 5. Did I say that fast enough? How do I find the y-intercepts? I set x to 0. If I set x to 0, I get negative 5y equals 10. If I solve for y, I get y is negative 2. And those are my x and y intercepts respectively. So if I go, my x-intercept should hit at 1, 2, 3, 4, 5. My y-intercept should be negative 2. That's here. Draw a straight line, I'm done. That's one method. What would be the other method? Solve this for y. So move your 2x to the other side. Now what? Divide by negative 5. If I divide both sides by negative 5, I get y is equal to 2/5 x minus 2. So dividing everything by negative 5 there, we get this. So how do you graph a line like this? You start at the y-intercept of negative 2, which is here. Slope up 2 over 5 gives you the same line. So your choice, I don't care. Okay, let's look at number 6. We're at 10 points. Sketch this. Oh, that's missing a squared. Please fix that. Number 10, that's missing. It should be 2x squared minus 8x plus 5. What type of function is this? Quadratic, good. How do we sketch quadratic function? Well, we have to look at what form it's in. What form is that in? Ax squared plus bx plus c, right? Yeah. All right. So what's the first step? We determine if it opens up or down. This one opens up, right? Opens up because a is equal to 2, which is positive. And then the next thing we do after we determine it opens up, we find the vertex. So we have to calculate h and k. H is equal to negative b, which is positive 8 over 2 times a, which is 2 times 2, which is 4. So we get 8 over 4, which is 2. Once we find out what h is, we find k. To get k, we plug that value of 2 into the function. If I plug 2 in there, I'll get 2 squared 4, it's 8, and then it's a negative 8, so I think I get negative 3. So my vertex is the point 2, negative 3. Next step, quick sketch. Quick sketch, Go out 2, go down 3. Vertex, it opens which way? Up. I do have 2 x-intercepts, right? So I have to go find them now. So I go find the x-intercepts. Do you want me to continue doing this? I'm just not quite sure if the speed I'm going through this is helping or just not matter. Should I continue at this speed or trying to get through it before we end class? We're all right? Okay, well, yeah, it is recorded. Okay, so now how do I find x-intercepts? Set that equal to 0. How can you do that? Well, try and factor, maybe synthetic. Nah, probably quadratic formula is what it's going to take here. So x-intercepts, set it to 0. Quadratic formula. And I'll just tell you what the answers are. I'm getting 0.78 and 3.2. 0.78 and 3.22 are my 2 x-intercepts. What do you find after x-intercepts? Y-intercepts. How do you find the y-intercept? F of 0, right? So plug 0 into the function and you get 5. So now we put it all together on a graph. Our vertex was 2, -3. Our x-intercepts, 0.78, which is about right here. 3.2, which is about here. Our y-intercept was 5. And it looks like a parabola, right? Like a U. So it's going to go something like this, and then do the same thing over here, and we're done. Questions? Number 7. So number 7, sketch f of x is x to the 5th minus 5x to the 4th minus 17x cubed plus 21x squared. Now, a lot of you did very well on this test, so I expect that you hopefully will get some good points from this by taking your time getting through this. All right, so this is a polynomial function. The first thing we do to graph a polynomial function is determine left and right hand behavior. This has a leading coefficient of 1, has a power that's an odd number. That means the left side goes down, the right side goes up, in the middle we don't know what it is. Then we try and find the x-intercepts. To do that, we set the function equal to 0. And the first thing you always do is GCF. Do I have a GCF here? X squared. Don't forget about that x squared. That x squared is actually going to be a place where your graph is going to bounce. Why is it going to bounce? Because it's squared. Good. So now we take the inside of that up. It's 4 terms. Okay, 4 terms. You try grouping. Grouping won't work. Since grouping doesn't work, synthetic division. You create your list. Your list comes from this number. There's a 1 in front here, so you don't have to worry about it. All the factors of 21. 1, 3, 7, and 21. So your list only has 8 numbers in it. You start doing your synthetic division on that piece. So 1, -5, -17, and 21. Let's see, will 1 work? 1 might actually work. 1, 1, 1, oh, maybe not. -4, -4, oh. -21, -20. It worked. First try. First try. What does that tell me? x minus 1 comes from that, and then this is going to be x squared minus 4x minus 21. So here's where I am. This thing has all turned out to be so far the x squared that was sitting out in front, the x minus 1 that came from here, and then these three things, x squared minus 4x minus 21. I want to know when that's 0. So now you have to go and try and break down this, right? You can again do more synthetic division if you're comfortable with that, or you can do AC method factoring. I won't show that step, but it turns out to be x squared, x minus 1, what is it? Negative 7, positive 3. And now you have your places where your function is 0. So we have 1, 2, 3, 4 places where it happens. Where are they? 0 from this, 1, 7, negative 3. What do you do at each of those x-intercepts? Cross or bounce? Bounce. Bounce because the power is 2. The rest of these powers are 1s. Cross, cross, cross. Right? Number line. Here we go. Here's 0, negative 3, 1. I don't like that. They're too crunched up. Let me try again. Negative 3, 0, 1, 7. That okay? Right side goes up, left side goes down. Okay, so I cross through at negative 3, I bounce off at 0, cross through at 1, come through here. Right there, 16 points. Next type of function is this. Rational. Now I use the variable p instead of x. Rational function. First step to rational function graphing is what? Careful. No, you're thinking of something else. Trying to sketch this. These were the steps. X-intercepts, vertical asymptotes. Right, remember all that? Horizontal asymptotes. There's a bunch of steps. Let's say that you can bring 4 cheat sheets to the final. 4 of them, because you had one for exam 1, for exam 2, exam 3, and then if you make a new one for the final, that's fine. So 4 total. X-intercepts first. How do you find x-intercepts? Set the top to 0. 2p equals 0. Well, that means p is 0. Divide both sides by 2. That's your x-intercept. Next thing, vertical asymptotes. Set the bottom equal to 0. That means p is 100. That's your vertical asymptote. Next thing, I might be going a little bit out of order here. This is your vertical asymptote. These are your x-intercepts. How about your horizontal asymptote? How do you find horizontal asymptote? Degree. Compare the degrees. What's the degree of the top? What's the degree of the bottom? Okay, same degree. What do you look at there, the same degree? Leading coefficient. What's leading coefficient of the top? What's leading coefficient of the bottom? Careful here. It's the number in front of the highest power, so it's the number in front of the p on the bottom, which is actually what? Negative 1. Negative 1. So your horizontal asymptote will be y equals 2 over negative 1, which is negative 2. We've not seen that before. It's a little tricky, right? Just a little bit tricky. What about y-intercept? Did we do y-intercept? Plug 0 into it. Plug 0 into this thing, you get 0. Now we put all this information down on a graph and try and figure out what the hell it looks like. My first thing is I had an x-intercept at where? 0, okay? The next thing, I had a vertical asymptote where? At 100. So let's say that's 100 right there. at a vertical dotted line. Then horizontal asymptote of -2. So let's say this is -2 right here. Only on the edges of my graph, I will have a dotted line coming out like that. -2, only on the edges. And then my y-intercept is actually the same as my x-intercept, so there's nothing to do there. So can you tell me at all what's going on? How about on this left side? This is the only point I know of, right? Do I know what happens to the left? It has to go down to this, right? So I'm going to go ahead and just go down there. Okay, now when it gets to this point, it might bounce and come back, or it might go up. So the only way to figure it out is if I do a test point. So let's say 50. If I test 50 into the original problem, right? Here was the original problem. This will be easy to plug 50 into, won't it? 2 times 50 on the top, 100 divided by 100 minus 50. 50, 100, 100 divided, whoa, yeah, 100 divided by 52. So it's positive, right? So it's up here somewhere. So what I know is that this thing goes up like this. Okay? Now what's happening on the other side of this vertical? Well, it's got to be down here, right, because of this. But as I move this way, I can't go up because I'd have an x-intercept, so it must go down. So without even a test point, I know it must look like that. So that's the graph of our rational function. 16 points. Number 9, 9 and 10 I'm not going to do, but I'll show you how they would go. I was surprised how many people missed a problem like this on the test. Look, if you're asked to graph this is an exponential function. How do you graph an exponential function? Table, x, f of x. What were the numbers we used? -3, -2, all the way till you get to what? 3? And you make your table, right? And you graph it, and when you do it, it should look like something like this. Now, on the next one, if I ask you to graph log base 2.5x, then what you're going to do is go back to this one, right? Because this is the same base as that, but that's exponential, that's log. Take these numbers, flip them over, and put those in a table over here and graph those. So when you graph the function, your function will look more like this. On the test, I was getting this for the exponential function, I was getting this for the log. So there's a pretty big disconnect for some students. That okay? I'm not going to make that table out. But how would you do it on your calculator? 2.5 to -3, and then you figure out what it is. All right, number 11. Oh man, I don't like to call people out, and I'm not going to. But like, I think if I asked people to raise their hand if they got the first problem on the test right, I probably would only have maybe 4 people. I think only 4 or 5 at the most. I think got the first one right. Some of the algebra I saw on that was like, I don't know, majorly disconnected. So let's try and get this, well, I mean, I guess you could avoid it completely and not do that one, right? But here's how it's done. 4 minus 3x over x plus 3. How do we find the inverse? We replace f of x with y. Then switch the x and y variables. So everywhere I see y, I put x. Everywhere I see x, I put y. Most people got that. And then from here, it was just all sorts of things that I saw. Okay? The idea here was first to clear the fraction, which means you multiply both sides by y plus 3. Over here, y plus 3. And I actually saw a lot of people do that too. And then over here, you have to distribute the x through, which means you get xy plus 3x equals 4 minus 3y. Saw a lot of that. But after this, I think a lot of people, the train went off the tracks. The idea is to try and get y by itself. To get y by itself. So what we did is we said, well, what has a y in it? That has a y in it. That has a y in it, right? So we will take both of those terms to one side of the equation. The things without y's go to the other side. So to get this negative 3y off the right side of the equation, what would I do? Add 3y to both sides. So I'm going to add 3y over here, add 3y over here. Can I put these two together? No, because they're not like terms. This one has an x and a y, this one only has y. So we're just going to put them side by side over there. Over here I need to get rid of the 3x, so I subtract 3x on both sides to get it to the other side. So negative 3x here, negative 3x here. So these cancel here, and what I'm left with is, on the left side, what? What's on the left side still? Okay, you can say xy plus 3y, or you could say 3y plus xy, either way. And then on the right side, what's left? You have this 4 and then take away 3x, or you can say negative 3x and plus 4. I'm going to say 4 minus 3x. The whole goal of that was to be able to have your y's together on one side so that you can do what on the next step? Factor out a y. Factor a y out here, right? Like a GCF type thing. You're doing a GCF on the right side. You pull that y out, and now you divide through both sides by what? X plus 3. Y is equal to this, and that's it. Then you switch it from y to f inverse symbol. Questions? Number 12? 4 raised to the 2x plus 1 minus 3 equals 8. This is an exponential equation. To solve it, we're going to try and get the exponential term by itself, so I add 3 to both sides. 4 raised to the 2x plus 1 equals 11. Now that I have my exponential term by itself, I'm going to rewrite this using, yes?
Sorry,
Did I skip something?
no, number 11.
It's its own inverse.
Um,
It can happen. It can happen. Was it exactly the same? Yeah. Let's see, if you plug in 0, 4, yeah, it's kind of weird that way, but it is. Good call. I didn't even notice it. I noticed it last time I used this review, but I didn't notice it this time. So. What do we do here? You rewrite it using the loop. So this is going to turn into a log, right? So the log, well, I should stress that. Because I saw some weird things on this too. If you have an exponential equation where your x is up in the exponent and you want to get it out of there, you're going to have a log in here. So just write down the log and then fill in these blanks, right? What will always go down here? The base of what's over here. So the 4 will go down here. The other side here is whatever that 4 is raised to. And then what goes here is what it needs to be equal to, 11. Now the x is by itself. It's not up in an exponent. It's right here. This side of the equation, change of base formula. Natural log of 11 over natural log of 4 equals 2x plus 1. What's natural log of 11 over natural log of 4? You do it on your calculator, you get some number. What is it? 1.72. So you have 1.72 equals 2x plus 1. Subtract 1, both sides. 0.72 equals 2x. Lastly, divide by 2, which is 0.36. Okay. Number 13. We have 2 log base 3 minus x plus 1 equals 7. The order in which you do this is important. Again, I saw these types of mistakes on the test. You're trying to get the log base 3 of everything inside. You're trying to get all of that by itself. So what I will do first is subtract 1 on both sides. Subtract 1. So I have 2 log base 3. Why am I trying to get the log thing by itself? So I can do what? Do that loop thing, right? Now what do I do? Get the 2 out of the front. Divide everything by 2, right? Not subtract, divide. Why am I dividing, not subtracting? Because that's implied multiplication, right? To undo multiplication, we come in with division. Now I do my loop. So this says what? 3 raised to the 3 must be this. 3 raised to the 3 must be 3 minus x. What's 3 to the 3? 27 must be 3 minus x. Subtract 3 on both sides. 24 is negative x. Multiply both sides by negative 1, or divide both sides by negative 1, you get the same thing. Negative 24 equals positive x. So the answer is negative 24. Okay, last problem of the semester that I'm going to do. So let's see. Log base 3x plus log base 3x plus 8 equals 2. There's not even any problems about the interest or anything on here, is there? There's interest problems. Y'all did good on those too, for the most part. All right, well, 2 logs, right? We're trying to solve this log equation. We have 2 logs, we turn them into 1. Operation between them is addition, so it turns into 1 log with multiplication inside. This becomes log base 3. I'm going to multiply this times this. So I distribute it through to both. So I get x squared plus 8x must equal 2. Now I can do my loop. 3 squared is 9. That must equal what was inside, x squared plus 8x. And you know what? I saw a lot of mistakes on this part too. You can, what I see students do with this, which is wrong, and I even see my calculus students do this too, is they factor the right side like this. And then they say, okay, that means x has to be 9, or x plus 8 has to be 9. Is that true? Is that right? Think about it this way. Let's say I said that two numbers multiply to be 10. Does that mean one of them has to be 10? Not, I mean, could it be? Yes, I could have 10 and 1, and that's true, right? But does that mean it has to be? No. I could do 5 times 2, couldn't I? That's 10. Neither one of them are 10. So if 2 things multiply to be 9, that doesn't mean that you set each one equal to 9. That only works with 0. If you put a 0 here, now The only way two things multiply to be 0 is if one of them is 0. Which is why when we're here, to work with this properly, we need to move the 9 over to the other side, which means we make it equal 0 like this. And now this is quadratic. And so you factor it or use quadratic formula. If we factor this, you get 8 plus 9, x, what did I say, 8 plus 9? X plus 9, x minus 1 is what I meant to say. So your two solutions are -9 and +1. And I'm not requiring you to check your answers. What's that? Equals 2. Oh, I looped it already. It was looped, right? Didn't I loop that?
Yeah.
What was it? It was log base 2x squared plus 8x equals, it was 3 here? And it was 2 here? Oh, so when I looped, I did 3 squared, right? Which was 9. It equals that. Oh, this. And then I brought the 9 over. So we're ending at like 40 minutes before the end of class. So I wanted to let you know, I'll go down to my office. If anybody wants to come down there and discuss their grade with me at all, just kind of get an idea of like, well, what do I need on the final or anything like that, I'll be down there. Just let me pack up and head down there, and you can just, I'll answer those questions. If not, I'll see you, Thursday. Make sure you eat. Make sure you get some sleep. Try not to come in here tired and hungry, all right? Have a good day. Yes.